Hi, let's look at the longest repeating character replacement, the Leetcode question to 424. Let's now understand how do we solve it and what the question is. So they've given a string here, for example, AB, and they've given a number k, which is equal to 2. This k number represents the number of characters that you can replace in this entire string so that you can form a longest substring. For example, if you take if you want to remove a character from the string and then replace it with b, the entire string would become b. Or if you choose to replace b with a, there is one b here and there is one b here in at the last index, right? So if you replace that with a, the entire string would become a, and if you replace the a's here, the entire string would become b. So this is a perfect. So they've also given k equal to 2, and the string also has at most two different characters. So this is fine. I think this example will give you a different um, good idea of what this problem actually is. So when you look at this problem, the first idea or the brute force approach that you will get is find all the possible substrings of the string. For example, you can go with you can go with this character as a substring, or these two will become a substring, this two will become these three will become substring. So you can mix and match and form any number of substrings. So which would lead to the complexity of O of n square, right? So you can check all the substrings you want, and then try to count the number of maximum occurrences of the characters in that particular string. For example, if you let's start from the beginning. So for index 0, if you start iterating through the string and when the index is 0, your substring becomes a. And the maximum, if you want to replace it with b, the maximum length of the substring will become 1, because you can only replace one element in the substring, or in general. So when your substring becomes a and a, which is index starting from 0 index and ends at 1 index, you can replace it with one element because the k given here is 1. You can replace one a with b, but your substring would be ab or ba. You can either replace the second a or the first a. If you replace the second a, your string would be ab. If you replace this first a, your string would be ba. But that substring doesn't have same characters in in the substring, right? So there are two different characters in the substring. So you need to have the same characters in the substring. That's when the substring is valid. And uh, yes, of course, it has to be the longest one too. So we have seen at the substrings a and a now. Now we'll go and check the substring starting from index 0 and index b. It ends at index 2. So if you so number of elements that we can replace is 1, right? So we'll replace b with a, and then we get a. This is a valid substring now. So this window is valid because all the elements in the substring are have the same character. So a is a valid string. You can also choose to replace the first a or second a with b, but then the substring would become bab or abb. So all the characters in the substring would not be equal then. So that this is not a valid one. So you can only replace b with a in this window. So if you replace b, then your window would become a, and the size of that substring will be 3, which is more than the valid substring that we have seen earlier, which was a. So this is valid and this is valid, but a is not valid. So now, because this string is valid, you again uh, try to increase the length of the window and check if that window is valid. And if that window is not valid, then you shrink it. So we'll check this window now. So we have AABA. So if you want, so there's only one element that we can replace here. So if you just look at it, uh, with common sense, we can just say that we can replace B with A to form AAAA, and that is a valid window. You can, of course, okay, again, you can choose to replace first A, second A, or this A at the last index in this window. But again, you will not get the maximum. Uh, all the elements in that substring will not be the same, which makes it invalid. So this is the valid window, and then we can replace B with A, and the maximum now becomes 4 because we replace B with A, and earlier it was AAA. Earlier it was 1, 3, and 4. So when you replace this A, if the substring is this, just the 0 index, so you can replace A with B, so your maximum window would become 1. And then this was the another valid substring that we encountered. So this, the length would become 3, and here the length would become 4. Now you check if this string is valid or not. So there are, this is where we cannot just look at it and say that, I mean, when you look at it and say, yes, you can say that if you replace A, any A, your all the elements in the substring will not become, all, the substring will not have the same characters. Or if you replace B with A, of course you'll have A, B, but again, your condition will not be satisfied. So this is an invalid window. So what do we do when we have an invalid window? We increment left. So the index now, new index will become this, and we wait for the left to catch up to right based on the condition, because this is a variable size sliding window. So we have to basically wait for left to catch up to the right to make sure that we have all the substrings, we check all the substring inside that substring. So we increment left, and then we earlier, so we basically take a dictionary, right, to keep a count of all the characters in that particular window. So when you shrink the window, we have to just drop the left and then increment the left. Yes, your right will, now your now your window will become this, and now you check again. So the maximum number of elements that you can replace is 1. So if you look at it now, you can just say that this is not a valid window, because if you replace A with B, so you can only replace one A, right? So even then you will not get all B's in this substring. And if you replace one A with B, you will not get, sorry, one B with A, you will not get all A's. So this is not a valid window again. So your left will shrink again, and then you will uh, remove the occurrence of that leftmost element from the dictionary, and then you continue to check whether this window is valid or not. Now, if you look at this window, BAB, so we have one A that we can replace it with B, so that the entire substring would become BBB, and we only have one element to replace, right? So we can replace A with B. So this is a valid window. So now um, you again check the length of this window, which is 3, which was less than the previous valid window that we've gotten, which was 4. We got 4 from this particular substring, starting from 0. Yeah, starting from 0, 1, 2, 3, ending at 3. So this was a valid substring. Now again, the valid substring would become this. So now the length would be 3, which is not greater than 4. So we will not replace the length. Again, you continue to do that for the to the entire string until you've, of course, until right reaches the length of the string, and you, based on the condition, you check whether or not you have to whether if you have to increment left or not. So let's see how we can code this. Let's take a variable 0, variable left, and initialize it to 0, and then uh, let's traverse through the string. Okay, now we have to keep the occurrences of the characters in the dictionary. So let me initialize a dictionary too. So I have now, I'll show you the dictionary. No, yeah. Do you want to see the dictionary by any chance? Okay, so we have a dictionary. So for the first example that's given here, so the number of, it'll basically store the number of characters in the entire string, but we're not deleting it based on the window size. So we'll do that now. Okay, so how do we know the if the whether the window is valid or not depends on, I told you that we have to check the so when you look at this and this, you can say immediately by through common sense that we have to replace B with A, right, to form the form to when I mean when you replace B with A here, you will get a substring of A, substring of length 4, which has all A's. So, but how do we do it in code, or like the logic that you have to use here is, so for example, this substring has a length of 4, right? To see if this substring is valid or not, we have to check the window size and then subtract the maximum occurrences of the same character. Like for example, the count of A here is 3 and the count of B here is 1. So when you subtract 4, which is the window size, 4 minus 3 would be 1. So 1 is equal to K. So that way you know whether it has to be basically less than or equal to K. So that's when you know that window is valid. So in the same way, um, if you check this window, so the window size here is 1, 2, 3, 4, 5, right? So 5 minus maximum count of the characters is 3 because A is 3 and B is 2. So 5 minus 3 is 2. So 2 is greater than K. So this is not a valid window. That's how we know logic. I mean, through code, that's how you know. Like, so I'll just take a variable maximum frequency and then initialize it to 0. So this would be the maximum of out of the dictionary, whichever character has the maximum count, I will be. So this will be the max frequency. So if you want to see the max frequency, I can print the left and right for you so that you will know. Or maybe, I don't know, maybe I'll just print the dictionary. That way it is easier. Okay, so the first dictionary that it has taken is 1, I think. So what did it print? The max frequency, right? So max frequency out of this dictionary is 1. Max frequency when there is 1 A and Yeah, when you have two A's and one B, the maximum frequency that it returns is 2, right? So it in a any window, it'll return the maximum frequency of the character. And now if we have to check if the window is valid or not. So we can either take a window size variable here, or we can just directly write minus left plus 1. So we can either take the window size and then we subtract the maximum frequency and then check if it is greater than k. So that's when your window becomes invalid. So once your window becomes invalid, you have to you have to decrement the occurrence of that leftmost element in the dictionary by 1. But if you might, so if that s of left doesn't exist in D, you get an error, right? So we will remove it if D of s of left is 0. We'll just delete D of s of left. Now we increment the left by 1. So because we incremented the left, we also want to check, um, I mean, if this window is a fixed sliding window problem, then I think we wouldn't have to replace the window size here. We don't have to change, but because window size changed based on the right and left, we can update it because left has been updated now. Right minus left plus 1. Now we have to calculate the length. So we'll take a length variable and initialize it to 0, and then the length, as I told you, it will be the maximum of whatever we have encountered until then. But the window has to be valid. Maximum of, it'll take the maximum of window size and length. Once it comes out of the while loop, it'll check the length, and then we'll return it. Yes. Let's see if everything that we've done so far is okay. I think that is it. So when we have what we are doing here is just incrementing taking the count of each character in that window and keeping it in D, and then we've taken another variable max frequency, and then it'll this maximum frequency will basically store whichever value in that D has maximum count, and then window size would be this, be it valid or not, this will be the your window size. So here is where you will handle the invalid window case. So if your window is invalid, which will be dependent on this condition, if this window size minus maximum frequency, again this condition is, for example, this window has the length of 4, and then maximum frequency in this here is 3. um, so 4 minus 3 is 1, and which is exactly equal to k. So that is a valid window. So it for this particular substring, it won't go into this while loop, but for this and for this, it'll go into the while loop and then change the left depending on that. So if you take this invalid window. So then it will go into the while loop, and then your window will become, your left will be incremented basically. So let's try if, yes, it's good. So the string that is given is AB, and then the expected output of 4, and then we got 4. We got 4 when they expected 4, and then now we'll try and submit. Yes, it got all the we got all the test cases passed, and then when you look at this window size, I think you can also avoid, you can avoid replacing, or I mean updating the window size by just not using the window size, but just I'll directly use this right minus left plus 1, because that's how your number of iterations will become less, because every time the you don't have to calculate the I mean, yeah, so only when, yeah, okay, yeah, so you can just avoid using the window size so that your memory, you're not using an extra memory space. That's it. I think this will give the same answer, but it should give the, we're basically using less memory here. So yeah, the time complexity is fine. It's the same like before, but let's see how much the space complexity becomes if we use window size. So it is 19.92 MB. Did I do something? Okay, I think, yes, just keep in mind that you have to use the, you don't have to use window size, so you just can use right minus left plus 1 to calculate the window size. That's it, unless you have to do those operations every time. Yeah, that's it. Uh, okay, thank you.